So the power rule can be solved using any application that is listed below. So, or to the side, sorry. So any variation that you see of this can be solved using the power rule. So the power rule states that if you have a function, say f of x is equal to x to the n, some nth power, and you want to take the derivative of it, the derivative of that function is going to be the exponent, that's n, times the base, that is x. And then what you're going to do is you're going to keep the exponent that x has, n, and then you're going to subtract 1 from it. So just again, to clarify, you're going to take the exponent that x already has, and you're going to stick it right here. Then you're going to multiply the base, which is your x, and then you're going to subtract 1 from its exponent. And that's it. So the first example we're going to do is a basic one using the positive exponent. So we have a function, I believe, f of x equals, let's say, x cubed. Okay, so first we got to identify our n. Our n is our exponent, right? So that's 3. Now we have another term that we want. It's n minus 1. So that would be n minus 1, which would equal 3 minus 1, which would equal 2. So let's just plug that into our derivative, our definition at this point. So our n right here, that's our 3. So let's plug in our 3. Then we have a multiplication, right? And then we have an x. That's our x right here. And then we have an n minus 1. Well, we have an n minus 1 here, right? And it was equal to 2. So we'll just plug in a 2 right there. So the end result is going to be 3x squared, right? Because you can just get rid of that multiplication point. So now we're going to try one with a coefficient. So let's just keep the same function and let's add a 2 to it. So f of x equals 2x cubed. Okay, so this is the exact same thing, except now all you're going to do is you're going to multiply 2 to the end result of the derivative of x cubed. So just kind of stick 2 to the side for a moment, and then you just focus on the derivative of x cubed. Now, normally I would do it again, but we just solved for it in the last problem, so let's just stick that right here. So that will be 3x squared. But if you didn't have a problem before, you would have to do the whole thing that we just did. So now all we do is we distribute the 2. So 2 times 3 is 6, and then we tack on our x squared. So derivative of 2x cubed is 6x squared. And if this was a 3, then it would just be 3 times 3, and then that would be 9. So pretty simple. Negative is exactly the same. So let's try with a negative one. So we have f of x is equal to x to the negative 3. Okay? So the same thing. We have the derivative of f with respect to x, and that's going to be n, which is negative 3, times our base, that's x, and then negative 3 minus 1, right? So it's going to be negative 3x to the negative 4, right? There we go. That's it. So that is the negative exponent. Now we're going to try it with a fraction. So let's say we have a fraction f of x is equal to x to the 3 halves. Okay, same exact thing. Literally no difference. You just grab your n, that's equal to n, so you have 3 halves as your n, multiplied by your base, which is x, and then you're just going to subtract 1 from the exponent. So 3 halves minus 1. That's going to be 3, it's going to be 3 halves x, and then basically what you're just going to do is subtract 1 from 3 halves. That's going to be 1 half, right? So the derivative of x to the 3 halves is going to be 3 halves x to the 1 half. That is it. Let's try one with a decimal. Literally the exact same thing. The whole process never changes. Let's have one x to the 5.1. Doesn't matter. So process still applies. Derivative of f with respect to x is going to be 5.1 times your x, n minus 1. 5.1 minus 1 is 4.1. Simplify it a little bit, make it look cleaner. And that's it. That's all there is to it. The last one we have is nth roots. This one's a little harder, and the only reason it's harder is because you have to first convert the root into a fraction as an exponent. That's the only difference. So like let's say we have f of x is equal to the square root of x, right? So when I say nth root, I mean something like this. This thing right here, this term is called an nth root. This is a square root if there's no number on here. It's an imaginary 2 if there's no number. But if there is a number, then it would be like, this would be like a cubed root, this would be like a fourth root, and then if you had like a 5, it would be like fifth root. So that goes on the bottom of a fraction of a exponent. So that sounded weird, but this is basically what I mean. So if you have the square root of x, that is the same thing as saying x to the 1/2. So you grab your nth root and then you just move it to the bottom of the fraction. So that's going to go right here, 1 over n. Similarly, if you had a exponent within the fraction, you would just move it to the top of the fraction. So this would be, or the exponent, sorry. So this would be x to the 2 over n. If this was 3, this would be the 3 over n. Okay, so now that we got that out of the way, let's solve a problem. So let's say 3, actually let's just do the square root of what we just did. So we convert that to x to the 1/2, and then we do the same process. We move our n, that's 1/2, multiply by our base, subtract 1 from the exponent. That is going to be 1/2 times x. 1/2 minus 1 is negative 1/2. So your answer is 1/2 x to negative 1/2. Similarly, if we had something like f of x is equal to x to the 3/2, you're just going to do, just gave you the answer. If we had the square root of x cubed, we would just make it x to the 3/2. So now we just do the same thing. We just say 3/2 is our exponent, multiplied by our base, subtract 1 from the exponent, and then boom, 3/2 x to the 1/2. And that concludes this video. I hope this helped clear up any confusion you had of the power rule.